I'll at least start recording. Please yell at me if you've ever seen me forget that. But yeah, today is a programming lecture, so we're going to be in Scratch again. If you would like to go there and follow along, that is, of course, scratch.mit.edu. Start creating. Beautiful stuff. All right, so today we're going to continue with the topic of loops. We'll study them a little bit more, and then I'll have us make a cute little game by the end of today. So let's go back to loops. Remember what loops do, right? Loops allow us to revisit code, so we don't have to type the same thing a million times. So our code used to look like this. It was just a bunch of straight line blocks. Do A first, then B, then C. Loops allow us to loop back and do A bunch of times. A, B, and C a bunch of times in order, which is pretty nice. And so we had discovered that there are blocks that look like this, right? And it was repeat. And then it was n times. And you got to choose whatever n was, that block. And then you got to put as many things as you want inside of this, and all that code got repeated that many times, n times, whatever you gave for n, okay? And this inner bit, I don't remember if I told you it last time, but this inner bit usually in programming is called the body. It's this is the head, this is the tail, or I guess the middle bit where all the code that gets repeated lives is called the body. That's the metaphor, okay? So we call that the body of the loop. So we say the body gets repeated n times, which is quite nice, okay? So yeah, let's go into detail with this, and then I'll have some fun examples. So words first. A loop, right? It's a kind of block that keeps getting run. It has its body keep getting run at least. You can specify how many times you want that body to run, or you can make it run forever. There's also a loop that is a forever loop. Did we notice that one? It's forever. Do the body. Never stop. Until I click the stop sign, just keep going. Keep going forever and ever. That is a forever loop. That can be part of our arsenal now. Forever. And what that does, of course, is it keeps running that body forever. If you put code down here, there's nothing to put there. You can't have anything. It keeps running forever. And I wonder if they made that apparent. Yeah, they did. Look at how cute that is. Okay. You see how you can have stuff after it's done repeating 10 times? You put stuff below it. Look what you can do with it forever. You can't have anything below it because it keeps repeating. It never stops. I appreciate that so much. So yeah, the inside of the block just keeps getting repeatedly run as many times or forever, okay? And we say that one execution of the body is called an iteration of the loop, okay? So we say that loops iterate. This is a Latin root just meaning to go, right? So loops iterate. And yeah, so those are two blocks that make hopefully enough sense. Repeat n times and then forever. Don't stop doing something. Okay, there is also a repeat until block. Where's that one? Boop, boop, boop. Repeat until. Keep doing something until this condition, you see how it looks, that pokey part, until a Boolean condition gives back true. Okay, keep repeating until a certain Boolean condition becomes true. And so if I draw that, boop, it says repeat until. Repeat until. And then you put your condition here. And that is, of course, something that gives back true or false. I'll call that cond for condition. And then it repeats its body, keeps running, repeat until that condition is true, gives back true. And usually you're going to change some stuff inside of the body, like change some variables, values, to make this condition getting closer to being true. Eventually it's going to want to stop, okay? That's the beauty of it. So I think with that, I want to give you an example of just the Scratch cat bouncing around forever, because that sounds fun to me. Are there any questions before I do that? All right, here we go. So, I don't know, do we want him to be like an astronaut? We can have him floating around in space, bouncing around. Where's that? We got stars. All right, Scratch Cat. Off you go. So, we'll start the program when the green flag gets clicked, and then forever, here's what we'll do. We will forever have the Scratch Cat bounce. Move a little bit and bounce. So, control, forever, Mr. Scratch Cat. Just move a little bit. Move 10 steps in your current direction, and if you're ever on the edge of something, let's start you off, blast off in that direction. And if you're ever on the edge, just bounce off. So where's that one? If on edge, bounce. Beautiful. Okay, so two pieces of code, 2 blocks in the body of the forever loop, and it's never going to stop. Whee! There he goes. Are there any questions about this code? Forever, do those 2 blocks. Can you imagine how hard it would be if you wanted this program to continue for a while and you didn't have loops? Like, you'd have to duplicate those 2 lines, those 2 blocks, like a million times. And even then, if you let it run long enough, it would stop. Forever will never stop. It's very convenient. Are we good with this? It's fun to watch. So let's see. Let's save this so you can have it later. And keep trucking then. So that's my first example. Pretty and graphical. I want to do a more numerical example next, because this is a very common thing to want to do in a program. So let us make a program that sums the numbers from 1 to 10. So we're going to add up the numbers from 1 to 10, okay? And I'll show you what I'm thinking. Here's what we'll do. We're going to make a variable that holds the sum, and it will eventually have the right answer. We have to start it off with something. So let's make a variable called sum. I'll make a little box, and let's have it start holding 0. We'll start off at 0. And then my idea is that we'll repeatedly add the numbers that we want to add into sum, like add the 1 in, add the 2 in, add the 3 in, add the 4 in, until we've added the 10 in. And then by then, sum will hold the correct sum from 1 to 10. Yeah? Just put all the numbers in one at a time. That's going to be my strategy. Okay? So we need to continuously update sum, that sum variable, and do this. Add 1 into sum, add 2 into sum, all the way to add 10 into sum. That will be a loop. Then we'll also need a second variable to keep track of what we're adding, because I want to do this in a loop. I want to have the same code that adds 1 the first time, 2 the second time, 3 the third time. In order to do that, I need a second variable. Okay? So I'm going to use, I'll just call it like 2add, 2_add or something, and start it off at 1. And then add the 1 into sum. That'll make it 1. Then change 2add to 2, and then I'll add the 2 into sum and make it 3. Then change 2add to 3. Add the 3 into sum, make it 6. You see how it's getting bigger, closer to the right answer? Make this 4. Add the 4 into sum, make it 10. Dot, 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 and I think the final answer is what, 55? 11 times 10 over 2, I think, is 55. Don't quote me on that, though. But, yeah, look at this repetitive process. These lines look almost the same. That should scream loop in your mind, okay? Eventually. These bullets are repetitive. Repetitive. So we should loop. Okay? And so that's what we're going to do. We'll need that second variable to keep track of which thing we need to add. And eventually we'll print the sum after we're done putting all the values into it and it holds the right answer. Okay? So I'm going to do this first using repeat 10 because we have 10 numbers to add. And then I'm going to show you how to do it using repeat until, because that's the better way, in my opinion. That's the way that helps you learn more about loops. Okay, but does anybody not understand the strategy? Does that make enough sense? 2 variables, they start out in those ways. Sum starts at 0, 2add starts at 1, and then we just repeatedly add 2add into sum, increment 2add until we've done it 10 times. Okay? That is what I want to do. So Here's how we'll do it. Let's see here. And then I'll draw what's happening when it runs. But let's make it first. So, file new. Okay. And so when the green flag gets clicked this time, let's make it just as we said. So we're going to have two variables, right? Sum better start off at 0, and then to add better start off at 1, we've decided. So I need my variables. I'll rename this default one to sum. I'll make a new one called to_add. Why not? If I want to, I can just check them so that they're both visible here. That's kind of cool. But then at the very beginning, I want sum to be 0, and I want to add to be 1. It's the first number to add into sum. Yeah? So that's the starting point. And then, repeatedly, I want to add into sum, increment to add. That's this process all over again. Starts off at 1, add it into sum, then make to add 2 so that I can add 2 into sum next. Okay? So let me do that in code. So 10 times I'm doing this addition, right? So I'll repeat this process 10 times of adding to add into sum, whatever it is right now. So let's see here. How do I want to do this? Yeah. Let's say set sum to be the addition of whatever it currently is and to add. Boop. Boop. See how it's adding whatever to add is into sum? Take its old value plus to add, set that to be new sum value. Okay, that's important. And then we want to increase to add by 1, so you can just say change for that. That one's easy. Change to add by 1. That'll make it 2, 3, 4, depending on what it currently is. The first time it'll make it 2, the second time it'll make it 3. So it just keeps on getting new values. Okay, and I would like to show you how this works. So I want you to see it happen in these little variable screens up here. So let's large readout. Interesting. Slider? No. That's cool. I didn't know you could right click on this. So I'd like to have it wait. That's all. I just want it to wait for a little bit. Just wait a second after you've done your first computation so that we can see it change. Yeah. And then at the very end, after this repetition is done, we've had it done 10 times, then let's have the scratch cat just scream to the world the answer. Like, I worked so hard on this. The answer is sitting in the sum variable. So say sum, please, for 2 seconds. Whatever that sum is. Okay? Are there any questions about the program right now before I show you it running? Does it make enough sense? Does it logically reflect all of the things that I said we needed to do? Please yell at me if it does not. So let's watch it work. Whee! Add 4 into sum, add 5 into sum, add 6 into sum. See it getting bigger? 7, 8, 9, 10. Yay! And the answer is 55. Yay! And he prints it out. So, interesting thing to notice, the 10th time we changed to add by 1, right? It started at 1. We did this 10 times. So it becomes at the end 11, but we don't use that 11. It's just the last value that we don't come back around and add it into something. Okay? So that might make us feel a bit uneasy, but we don't use the 11. It's just getting to 11. Okay? We want to see it again. Does that make sense? Add it in, add it in, add it in. Set sum to be sum plus to add. To add is changing one at a time. Sum is increasing by that amount. The answer is 55. Yeah? So let me draw what's happening slowly, now that we have some code to look at. So at the beginning, the first 2 blocks, these guys, make variables. So set sum to 0, initialize, right? And set to add to be 1. Sum is 0, to add is 1. And then 10 times we do this process. Set sum to be whatever it is plus to add. So sum is equal to itself, 0, plus to add 1, total 1. So sum is going to be 1 now. Okay? Then change 2 add by 1, that makes it 2. Wait a second. We don't need to wait a second in our diagram. And then we repeat again. So that was the first iteration of the body of this loop. Now we're back. Now sum is 1, 2 add is 2. We're going to set sum to be sum plus 2 add. So sum equals whatever it is, the 1 plus 2 add the 2. Now it's 3. That answer is 3, and we put 3 into sum. See how that's working? Change 2 add by 1, now it's 3. And we're going to do that, what, 8 more times? So now add 2 add into sum again, make it 6. Change 2 add by 1, make it 4. Add 2 add into sum, make it 10. Change 2 add by 1, make it 5. Okay, and eventually, boop, 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 we're going to have 2 add being 10, and sum is going to be 45. We'll add the 10 in for our last iteration of the loop, right? We're going to set sum to be whatever it is plus 2 add, so make it 55. And then we'll change 2 add by 1 again, 11. It's a useless thing to do at this point, but the whole point of a loop is doing the same thing a bunch of times, so it's still going to make it 11. And that is when we're done. We've done it 10 times, we can stop. Any questions about that now that I've drawn it out? Everybody see how that's executing? It's very important to understand. Because I like to change this loop to not say repeat 10. That's kind of easy and cheating. Not a real loop in my opinion. I'd like to change it to be a repeat until loop. So what's true when I want to stop the loop? Does anybody have any ideas? Like, what is true when I want to stop this loop? What's a good condition? Do you have any ideas about that? Sum is 55. We could be like, stop the loop when the sum is 55, but we didn't know the answer. That was the whole point of this program. I think that's not a useful condition. We also have 2 add, though. How do we know we've done it 10 times already? Can we look at 2 add and say, like, oh, I'm good now. We don't have to add any more. What's a good value to know we've done it 10 times? That's a good observation. So the second 2 add gets to 11, we don't want to add in 11, so we would like to maybe stop this whole process. Stop when 2 add ever gets bigger. 2 add is strictly bigger than 10, because I don't want to add anything more than 10 into sum. Stop when this is true. Stop when 2 add is greater than 10. Repeat until 2 add is greater than 10. And you could change this condition to be other things, but that's the obvious one that comes to my mind. Let's do that. Let us extract this one. I'll put it over here so you can have it again. Duplicate. There you go. It's over there. Now I'm going to change this. This is going to be not repeat, but repeat until. And this whole body's coming over here. There we go. Zoom back in. So repeat until, do this process until I have no more numbers to add. I don't want to add anything bigger than 10, so repeat until 2 add gets bigger than 10. Okay? So let's see here. Repeat until 2 add is bigger than 10. And right now at the end of the program, it's still 11 right now. See how that's true? But when 2 add is 1, if I made it 1 quickly, that's false. It's false until it gets so big I'm done adding. Repeat until 2 add is greater than 10. Okay? And this is going to do the exact same thing. Because the second 2 add becomes 11, that's greater than 10. It's true. There's no need to continue. Repeat until this, and then stop. When it comes back down here, the answer is still 55. Okay? Questions about that? Isn't that fun? So that is math. That is coming up with the condition we need here. There we go. All right. So with that in mind, I'll give you this on the screen in case you didn't get it down on your own window right now. What I'd like you to do is to get into peer instruction groups, say hi to your neighbors, and help each other. Instead of writing code to sum the numbers from 1 to 10, write code to sum the numbers from 1 to 25, but only the odd ones. 1 plus 3 plus 5 plus 7, all the way to 25. Okay? So definitely use this as a starting point, but see if you can come up with the proper program that's going to calculate this. All right? I'll give you a few minutes to try that. What would you change? Take about 15 more seconds. At least that's what my timer says. All right, did anybody get it? What needs to change? It's very similar to this code, isn't it? What pieces need to change? I think sum is pretty happy, right? Sum needs to start at 0 no matter what, otherwise the answer's wrong, right? We just add, we need to change sum by 2 add each time. That's pretty set in stone. I think it's 2 add that needs to change, right? So the first number we need to add in is 1. The next number is 3. How do we fix that? Because right now it's going to make it 2. What needs to change? Mm-hmm. Great. Yeah, because then it'll increase by 2 each time. Mm-hmm. Did everybody get that? So that'll make it 1, 3, 5, 7, 9. Keep on adding those into sum. I think there's one other thing that needs to change right now, because right now it's going to stop at 9 with the current code, isn't it? Repeat until 2add is greater than 10. Once it gets to be 11, it's going to be like, I'm done. How do you let it continue until 25? What are we thinking? Yeah. What should it be changed to? What was that? Yeah, 25 would work. Because 25 is the last number I want to be added into there. If it ever gets bigger, I'm done. I want out. Yeah. We want to keep it when it's 25. So keep going. It's still, this is false. When 2add is exactly 25, it's not greater than. It's exactly that, so it's still false. But then once it gets to be 27, then it's done. Now it's bigger. Now 27 is bigger than 25, and it will stop the loop. It will not continue. Good. So that is the solution. Are there any questions about that? We were a bit slow to answer today. I'm not sure if we're just tired because the week is long or if we're not understanding. I need to know if it's the second thing. Okay? Please yell at me. All right. So I have another example if we're ready to move on. Because this is loops involving conditions. We have something else that involves conditions, and those are conditionals, or if statements, or if blocks, if-else blocks. So it's getting close to Halloween. Close enough. So here's my silly little example. Let's call it, do you believe in ghosts? And it will help us learn about these Boolean operations, these and, ors, and nots, the things that we learned in the truth tables, and just coming up with conditions in general that give back true and false. Okay? So here's my silly little idea for this program. So we're going to ask the user, hey, do you believe in ghosts? Okay? And if they do believe in ghosts, we are going to change a variable. We're going to have our ghosts in the background, right? Our ghost characters. They're going to be listening for this variable called should show ghosts. Why not? So we're going to have this should show ghosts variable maybe start off with 0. But if the user says they believe in ghosts, we're going to make it 1. And that will show the ghosts because they're going to be listening for this change in this variable. Okay? So the ghosts are going to be summoned depending on the value of should show ghosts. We'll hide or show them with hide and show blocks. And they're going to be looking for that variable, being a 1, to show themselves. They're going to just keep on watching that variable using a forever loop. Okay? So I think this is going to make more sense when I actually program it. But that is my plan. Okay? So we're going to have some conditions being checked here. This variable is going to drive everything. This should show ghosts variable. Okay? I believe I saved this one, so let's make a new file and set the scene. So I think we have like a woods scene. Maybe that's the scariest place to be. So we have the scratch cat, and let's have 3 ghosts. A bat. Let's pretend a bat is a ghost. I think there's a real ghost somewhere, so let's definitely find that one. Ghost. Yay. And then I think there's also a skeleton, so let's have a skeleton as well. So these are scary objects, and they're make-believe, so the scratch cat only gets to see them if he believes in them. Okay, so let us make this that one variable again to keep track of this. So rename this default variable to be should show ghosts. It can be anything, but I'll call it this. And if that's ever a 1, the ghosts should be showing themselves. Okay? So here's how we'll run the program. So when the green flag gets clicked, we are going to ask the user, hey, do you believe in ghosts? Where is that? Dun, dun, dun. Sorry, is it in control? Oh, there it is. It's in sensing. I always forget. Do you believe in ghosts? And wait. And then the user would hopefully type yes or no, right? And depending on what they type, we're going to set that should show ghosts variable. Okay, so boom, boom. We'll have if then else. So if the user believes in ghosts, they typed yes, right? If their answer was equal to yes. So there's an equals operator. If their answer was equal to yes, then we'll set that should show ghosts variable to 1. Otherwise, we'll set it to 0. Okay? That's how that'll work. And then the ghosts are going to be listening for this. So when the green flag gets clicked for a ghost, they should start out hidden, of course, because we're not sure what the user thinks yet. We're not sure if they really believe. So we're going to have them be hidden. That's in looks, isn't it? Yeah. So all the ghosts start out hidden, and then they're going to keep on watching. See if that variable ever changes. So forever check and see. Check and see if that variable changed. Okay, so if should show ghosts is a 1, then I can show myself. Otherwise, I'm already hidden. I don't have to do anything. If that variable got set to 1, oh man, that means the user believes in me. I should show myself. Does that make sense? So we have no control over how fast the user types. Only once they're done typing do we run this if block, right? Setting the variable to 1 or to 0. But the ghost starts out hidden, and it just forever keeps checking. Like eventually, the user is going to type enter, the value is going to get hit into the answer variable, and we're going to, in the scratch code, set this variable. And then if it ever becomes a 1, we'll have the ghost show itself. It will forever be checking that. Okay, any questions about that? It's an if within a forever, but the whole point is we need to keep on running this because maybe at the start of the program the user hasn't finished typing and should show ghost is still unset. We need to show those ghosts only if it becomes a 1. Okay. I think there's a bug in this right now, but we'll fix it. So let's give this program to the other 2 ghosts. I can just drag it to them. Take it, Mr. Ghost. And then please take it also, skeleton. So now all these 3 ghosts have the same program that forever keeps checking like this. Let's see here. Yeah, I think that is, I think that's what I want. And yeah, let's start the program. Bam. Do you believe in ghosts? And the user hasn't typed anything yet. And so at the very beginning, all of our ghosts, see how this is all yellow? So there's a yellow background around all the blocks. That means it's running. This is just running forever and ever and ever now. The ghosts initially hid themselves, and forever they're checking for that should show ghosts variable to be 1. Right now, the variable is set to 0. So do you believe in ghosts? If I say yes, hit enter, or click the checkbox, they all show themselves, yay, because this variable got set to 1. And that caused this inner body of this if to fire. You see that? And this program is still running, by the way. It's still checking, hey, it should show ghost 1. If so, I should show myself. It's just showing itself all the time right now because should show ghost is still set to 1. So it's doing a lot of extra work. That's okay. It's making sure. Okay? Any questions about this program so far? So ask the user for something, check a condition, set a variable, and then all these guys are listening for that variable to change. But there is a problem right now. It has to do with initialization because... What do you mean 1 or 2? Oh yeah, that's whatever. This is just the code that I have been using. So you could... Instead of typing yes, you use 1. You type 1, will it register it as true? 1 is not equal to yes, though. I'm checking for exactly yes right here. Yeah. That's right. If I run this program again, what do you think will happen? Will it do it right? No. The ghost should start out hidden. They're hiding, but should show ghost is still set to 1 from the previous run of the program. See that? So we better have initialized that variable at the very beginning. See that? That's what really needs to happen. Alternatively to all this, you could have an if-else if you'd like. And then you don't need an initial hide. It'll just be whatever the if-else gives you the first time it runs through the forever loop. Maybe that's cleaner in your mind. You can change it to this. Oh, sorry, this still needs to be within the forever, though. Come on. There we go. This would also work. If should show ghost is 1, then show else hide, and it'll just keep watching for a change. At the very beginning of the program, it's set to 0, so they will hide themselves. And then it's listening for it to change still, so if it's ever a 1, it'll show itself. If it changed multiple times throughout the program, if we allowed that, then this would be the only correct way to do it, because it would just keep on checking for the value to change to be one or the other. Okay, so maybe that's a better way. Let's give that to everybody. But you really do have options as a programmer. There's a million ways to do the same thing, like I've been saying. So forever, check for that variable to change. If so, if it does get to the 1, then show the current sprite, else hide the current sprite. And so that same program is working for the bat, the ghost, and the skeleton. And this initialization, we have discovered, is very important. Okay? So at the very beginning, set should show ghost to 0, which is perfect, because that will allow this forever loop that keeps on checking to notice that this is false and hide the ghost. If I type no, no is not equal to yes, so it's going to set this to 0, and the ghosts still remain hidden. Everything's fine. They're still listening, though. This program's still running for the bat, the ghost, and the skeleton, because it's highlighted like that. It's forever doing this until I stop the program. If I restart, type yes this time, then it does set the variable to 1, which wakes up all of the sprites over here, because this will be true, which shows them. Okay? Any questions about that? It's a fun little interaction among sprites, listening for a variable. All right. So here's the idea. Here's how it's working. Let's just write it down in words. So when I enter my answer, the answer variable got changed to whatever I typed, right? So it was here, and I checked against whatever the answer variable held. I checked it to be. I checked whether it was true. Okay, whether it was equal to yes, whether that answer was true. If so, then I changed the should show ghosts variable accordingly using an if then else block. Okay, that was that. And then each ghost continuously, forever, kept checking that variable. And they hid or they showed themselves, depending on what it was set to. So if it was a 1, they showed themselves. If it was still a 0, they kept hiding themselves. Okay? And maybe we can ask the user again, if they type no the first time, if we're in the else case, are you sure? And then we could set it to 1 another time. So because they're continuously checking, we're allowed to hide and show them if the user changes their mind. They get too scared. So maybe that's a new version of the program you could write yourself. Okay. Any questions about this? Because I want you to play around with it for a few minutes. Let me give it to you on Discord, if you would like to log in on Discord and get this. Otherwise, I'll just keep it open. Scratch Project 2, apparently. There it is. So I'll give you that the only way I can. And then I have a question for you. Maybe you can start thinking about it as Discord updates itself and opens, and that'll take an hour. So here's my question for you. I'd like you to recreate this example, or use my code, and add something to it. Change it so that you can convince yourself you understand how it's working, okay? Maybe make the ghosts all say boo when they appear, something like that. But see if you can make a cool one and make your neighbors jealous. Let's see here. So I need this window. I want to drag that to there. Go. So if you'd like it, I think you have it now. And I think we're good. Boop. So yeah, take like 4 minutes or so to have fun with this, and let me know if you have any questions. And if you'd rather just copy it from the screen, tell me which sprite you want to look at right now, and I'll change the code to show you that. So yeah, do something different. Again, here was the question. I'll leave that up for a second. And then here's the other code if you wanted to look at that. Another minute or so. Have fun with this. Like nice. All right. Did any questions come up while we were trying to do stuff? Happy with this? I have one last example for the day. If we're good to continue, I will teach you how to make a very simple game. It's called a platformer game, like Super Mario's a platformer game. What others are? Like the original Sonic games or something. Not a lot comes to my mind, but the reason it's called a platformer game is because you're like moving from left to right, and you're able to jump on these little platforms. You can go up, go down. It's 2D, side-scrolling kind of thing. And you can interact with the world, of course. And so I'm going to teach you how to make essentially that in Scratch. So we need to figure out how to make a character move around. We'll also have jumping, because that's like a key feature of a platformer game, right? And then we'll have some sort of interaction with the world. So here is, let's get started with the movement at least. Let's do this. My silly game is going to be the Scratch Cat jumping up to eat fish, because surely all cats like fish, right? So we're going to need an underwater backdrop, of course. Ocean, underwater, there we go. There's a Scratch Cat. You can give him his real name. Not that it really matters, but he probably appreciates it. And then eventually we're going to need like a little fish for him to come up and catch. So he'll be eating that fish today. So here is what we can do. So to move, let's see, horizontally, it's really easy. Watch. The event will be when like the left arrow is pressed and when the right arrow is pressed. Right? When you press left, Scratch Cat should go left. When you press right, Scratch Cat should go right. What is left and right in terms of a coordinate system? It's just the Scratch Cat's x-coordinate, right? So if you want the Scratch Cat to move to the right, make his x-coordinate a bit more positive. If you want the Scratch Cat to move to the left a little bit, make his x-coordinate a bit more negative. That's not bad, right? So we can change that. We can use motion. We can be like, when the left arrow is pressed, change x by -10, because we want him to go to the left, towards the negative x direction. When the right arrow is pressed, change x by +10. And that's going to make him walk. Whee! There he goes. And you can hold it in, and he'll glide over there. Maybe 20 is better, -20 and 20. Makes him move a little bit faster with each key press. But that's super easy to make that happen. That's beautiful. Cool. Yay. Okay, so that is my left and right. Now we need jumping. All right, so let's make it so the Scratch Cat can jump. Here's how we'll do that. So what is jumping but changing the y-coordinate, right? So to jump, the Scratch Cat better move straight up. That is, change the y by some large amount. That'll make him jump, right? So to start off the jump, I will increase the Scratch Cat's y value by a ton, and then we'll bring him down slowly, so there's like an animation of him falling. But like the jump is super quick, and then he'll fall down slowly. Okay? Because he put a lot of energy into that jump, of course. Okay, so let's have a jump happen when the space key is pressed. That's a pretty common jump action. Jump key to use. So yeah, when the space key is pressed, let's mess with his y-coordinate. Change y by a ton, like maybe 150, I don't know. Does that seem like a decent enough jump? So I'll press space. That's pretty high up. Let's say, yeah, that's probably fine. Maybe that's good enough. 150, what about 175? Let's see. Yeah, that's to the fish. Let's make it 175 then. And then we need to bring him down. So he went up 175. He needs to fall down 175 now, doesn't he? And we want that to be animated. So let's make him fall slowly by changing y like -25 at a time, maybe. That goes in cleanly to 175. If I do this block, how many times it'll make 175? It's 4, 5, 6, 7, right? 7 times -25 will bring him down 175. Let's try that. So repeat 7 times. negative 25 or something. So, oops. Oh, sorry, not set y to negative 25, excuse me. Change y by negative 25. Let's try that. There he goes, he falls. And I'd rather he fall a bit more slowly, so maybe we can make it 180. And then 18 times he can fall by negative 10 at a time. That'll again bring him back down to where he was. And that's a bit cleaner of a jump. More animated. More frames. Okay, so go up 180. That's the jump. He immediately goes up. And then let him fall back down. That's jumping. And then you can move, jump some more. And that's almost a platformer game. Are there any questions about these things I've written so far? Isn't that fun? So, yeah, the goal now should be, let's make the Scratch Cat be able to jump up and, like, get that fish, right? We'll, like, keep track of points or something, so every time the Scratch Cat touches a fish, he will, like, get a point, something like that. So let's make it like that. So let's make a variable that keeps track of our points. And we can just check it so it's always visible. And then it should start at 0 when the game starts. Maybe the fish can keep track of the game starting. This is the fish's code I'm working on now. So the points get set to 0, and then repeatedly, let's have the fish be the one who's keeping track of, like, hey, did the Scratch Cat touch me? If so, I've been eaten. That can be the fish's problem. So forever, keep on checking if the Scratch Cat is touching you. Something like that. Forever, Mr. Fish. I'm in the fish's program right now. Forever, keep checking if the Scratch Cat is touching me. There's actually a sensing operator for that. If I am touching, it's always from the perspective of the sprite whose program you're writing. So this is the fish's program. So it's if the fish is touching the Scratch Cat. Then, if that's ever true, we should give the Scratch Cat a point. Okay? We should change points by 1. Something like that. So now the green flag gets clicked. The Scratch Cat's able to move around with these keys. And then the fish is forever keeping track of whether or not the Scratch Cat is touching him. He's not. If he ever is, increase the points. And it seems like the points increases by 3 right now every time. Because for 3 frames, the Scratch Cat is on top of the fish. It's touching the fish. So that's kind of not fun. That's kind of incorrect, right? So only when we touch the fish once should the points, or once we touch the fish, the points should go up by just 1 at a time, not 3 at a time. And the reason this is happening is because the Scratch Cat is touching the fish for a while, okay? So here's how we'll fix that, okay? The fish, we'll make that fish disappear so that it can't be touched anymore. The second the Scratch Cat is touching that fish, we'll make the fish disappear, okay? And then we'll also make it teleport to some other place after 1 second. We want this fish to stay along this line, so we'll mess with the fish's x-coordinate only. We'll give it a random x-coordinate to teleport to. Okay, so this will be the idea. If the fish is touching the Scratch Cat, then, change points by 1, sure. We should also hide the fish. Where's that? Looks, right? Hide the fish so he can't be touched anymore. Teleport the fish somewhere. So go to random x position, essentially. Set x to be, or sorry, change x. Maybe that would help. No, I'd rather do set x, actually. Let's set x to be a random value. Pick random between, let's see, the fish could go over here. That's negative 150, and how about negative 150 and positive 150? That'll do it. So that will teleport the fish somewhere, but he's hidden, so we couldn't see the teleportation happen. And then maybe after a second, we'll wait a second to show ourselves. And then the fish will appear at that new random spot. Does that make sense? This order of operations. If the fish is ever touching the Scratch Cat, then the Scratch Cat just got a point. Hide the fish, teleport the fish somewhere else, wait a second, and then show the fish. And this will all work together in a nice way. Boop. And we only got 1 point. Random location. Random location. Jump up. 3, 4. Isn't that cute? I guess it's not so fun for the fish, but it's fun for us. So that is my fancy program. All the work is happening in the fish, really. Just the movement's happening in the Scratch Cats program. And then the fish is the one keeping track of the points, figuring out if it's touching the Scratch Cat, and getting itself ready for the next iteration of the game. It's got to be in a new place so that the Scratch Cat can get more points and move around. Okay? When you stop the game, start it again, the points gets reset to 0 because we initialized it. Yeah? Any questions about this? That's kind of fun. All right, so I'll save this so that you can have it. And that is the lecture content of the day. I would now like to release your next programming assignment since you have one due. So programming assignment 2. This one will be due September 1st. So I think you're getting the hang of it now. This is a week and a day from now. So here is your objective. If you've never programmed before, if you're in this group, then make a Scratch program with the following features. I've done a lot of this for you, so you can copy a lot of what I've done. So you need a character walking around with the left and right arrow keys, and the character should also be able to jump with the space key. Okay? Then you need to make something cool happen when you touch or jump into another sprite, just like I did today. Okay? You also need at least 2 looping blocks in your program. So a forever block or repeat block, those count as looping blocks. Anything that can come back around along itself. You can totally use my lecture demo to start, but your something cool cannot be exactly what I just did. Like pick new characters. When you hit the character, they disappear and go some other random place. That's what I just did. You can't do that. Okay? So your something cool needs to be unique and different. Okay? Let me know if you're having any trouble coming up with the unique thing. I can help you. And yeah, that is your objective. That's make your own platformer game, kind of in the style that I was showing you today. So come up with a fun idea and then use my example as a starting point. And this time, upload a video, okay? If you weren't able to do it before, this is now required, so see me. I will not give you credit unless you send me a video for this assignment onwards, okay? So demonstrate your code running. Show me the code, show me how it's working, explain that you understand it. It doesn't have to be long, just like 30 seconds, a minute long. Just show me everything, and that will be your program. Any questions about this one? Hopefully that's self-explanatory enough. If you're in the You've Programmed Before group and you don't have a special assignment that we've talked about already, then here is your exercise. You'll read these chapters of that book, and you'll do exercises 6, 7, and 8. Again, please record a video and show me your code working, all the cool things happening. Okay? So that will be due a week and a day from now, and that is your programming assignment 2. Any questions about either of those before I stop the recording? All right, you know what to do.